Okay, today we're working on Course 3, Chapter 1, Lesson 6, Scientific Notations. We're going to put a heading on our math paper. This starts on textbook page 51. We only have one vocab term for this lesson, and it is scientific notation. So what is scientific notation, and what do we use it for? Scientific notation is when a number, is written as a product of a factor and an integer power of 10. Okay, there's a couple things you have to keep in mind when you're doing scientific notation. One of them is that your factor has to be larger than 0 and smaller than 1. So what does that mean? An example of scientific notation would be 4.25 times 10 to the 7th. Okay, that is in scientific notation. There's your factor. It is greater than 0 but less than 10. Here's your power of 10 that you're multiplying it by. We use scientific notation a lot in science. Okay, a lot of the things that we examine in science are either too small or too large to express using standard form numbers because they would just take up way too much space, either on a calculator or even to write down. So it's a shortcut way to write really, really small numbers or really, really large numbers. Couple other things. If the exponent is positive, that means you're talking about a very large number. And then opposite, a negative exponent means you're talking about a very small number. So very, very large number would be like distance between planets. Very, very small number would be the measurement of an atom or something on a cellular level. We're going to practice going from scientific notation to standard form and then also from standard form back to scientific notation. First set of examples we're going to do, we're going to write in standard form. Five and 34/100 times 10 to the 4th power. Now we did do this in 5th grade. We learned how to multiply numbers by powers of 10. If you wanted to, you could rewrite your power of 10 as a standard form number, but you don't want to have to do that. What I am going to do though is I'm going to rewrite my number with lots of space so I have some room. I'm going to look at my exponent. Remember that when we multiply by powers of 10, all it really does is move our decimal point either to the right or the left. Since it's a positive exponent, my number is going to get larger. That means it's going to move to the right 4 times because my exponent's a 4. 1, 2, 3, 4. This is where my decimal point's going to end up. Well, I have empty swoops, as you guys are used to me saying. So I'm going to fill those empty swoops in with zeros, and then I'm going to rewrite my number without any mess. 53400. Go back and add my comma. So my answer is 53,400 in standard form. Example 2. 3 27/100 times 10 to the negative third. Well, this is a negative exponent. Up above, I said that negative exponents are going to be smaller numbers, so smaller means I'm moving to the left. 3 times. Negative 3 means left 3. I'm going to rewrite the number so I have some space. Then I'm going to take my different colored pen and I'm going to do my 3 swoops. 1, 2, 3. Put my decimal. Fill in my empty spaces with zeros. And then rewrite the number in a much neater way. 0.00327. I am going to pause, or you are going to pause the video so you can do A, B, and C in your notes. Then you can restart it and check your answers. The answer to A be 742,000. You had to take 5 swoops to the right. For B, you should have taken 2 swoops to the left, which would give you 0.061. And for C, you have a positive exponent of 2. You should have gone 2 to the right, ending 371 and 4/10 is where your decimal would end. So that is writing in standard form. We're going to practice going back the other way. We are going to write this set of numbers in scientific notation. I'm still looking for powers of 10 here. Example 3 is 3,725,000. Remember that when I have a whole number like this, my invisible decimal place that I don't see is furthest to the right, and I need 1 digit in front of my decimal. So I have to get from here all the way to here between the 3 and the 7. That way there's only 1 digit in front of the decimal place. I'm going to count those jumps. 1, 2, 3, 4, 5, 6. So I'm going to write that down. Then I'm going to ask myself, okay, 6, was that positive or negative? Well, it started out as a really big number, so it's going to stay a positive exponent. And then I'm just going to rewrite what's left. 3.725. Get rid of those zeros. That's the whole point of writing in scientific notation. And it's times 10 to the 6th power. Example 4. 0.000316. Well, that's a really small number. So I know that's going to be times 10 to the negative something. So I'm just going to go ahead and put that in there. Once again, I want 1 digit that's not a 0 in front of my decimal. I need to go between the 3 and the 1. I'm going to count 1, 2, 3, 4. It takes 4 to get there. And all I have left now is 3.16, or 3 1600ths times 10 to the negative 4th power. Okay, once again, you're going to go ahead and do D, E, and F. Pause your video, and then come back and see me. Okay, D should be 1.414 times 10 to the 7th. E is a really small number, so it's going to be 8.76 times 10 to the negative third power. And f is 1.14 times, again, that number is small, so it's a negative exponent, 10 to the negative 1. Now remember, we don't have to write positive 1, but we do have to write negative 1 when we're doing scientific notation in order to keep track. I'm going to stop this video. I want you to do guided practice problems 1 through 4. You are going to post those in your remote learning. And then we will do examples 5 and 6 from your textbook together in class tomorrow.